Hello, this is a look at the Chapter 7 individual test. First question was related to a sequence, and you can see I have a sequence here that starts with the value 10, it goes to 50, and then the next term is 250. Um, One thing that we're always looking at is this sequence arithmetic or is it geometric? And the difference is in the generator for the sequence. If a sequence is geometric, if it is geometric, it is always the case that we get new terms by using multiplication. And we should be careful, it doesn't always have to grow. It depends on what the multiplier is. So if the multiplier is a number greater than 1, for example 1.5, and that's what we are repeatedly multiplying by, then we will have growth. If the multiplier is a number less than 1, for example 0.76, um, if I keep multiplying by 0.76, this sequence will be decreasing. But they're both geometric because we're growing by multiplying by the same thing again and again. And again, we show repeated multiplication using exponentiations, these exponents. This notation tells me how many times I'm multiplying by 1.5. So for example, if I start with the number 10 and I multiply by a 1.5 just once, that's what happens when x is 1. But if x is 2, I multiply by 1.5 and another 1.5. If x is 3, I multiply by 1.5 three times. So remember, this exponent right here tells me how many times do I multiply by this base, this 1.5. Right, so I'm multiplying by it repeatedly. So in this sequence, when I look at it, it is geometric. The other kind of sequence is arithmetic, where we're adding the same value again and again. But this one's geometric. As I move from my first to my second term, I am multiplying by the number 5. And as I go forward again, I am multiplying by the number 5. If I want the next term, I would multiply by the number 5 again, and 250 times 5 would be 1,250. So my fourth term is 1250. The generator for this sequence, right, because it is geometric and I'm repeatedly multiplying by 5, my generator is multiplication by 5. What kind of sequence is it? This is geometric. And I can tell because it involves repeated multiplication. Or I guess I'll say uses repeated multiplication. The last thing it says is write an equation in the form y equals a times b to the x that correctly produces the values for this sequence. Well, I do need to know the zeroth term in order to do this correctly, and I can see that as I move forward I'm multiplying by 5. So if I take this first term and divide by 5, right, if I go the other way and divide by 5, I would land at the number 2. So my zeroth term is 2, and this equation would be y equals 2 times 5 to the x power. And again, you can verify this, but when I plug the number 1 into that, it produces 10. If I plug 2 into that, it's 25 times 2, which is 50. If I plug in 3, let's see, 5 times 5 times another 5 is 125, and if I double that, it's 250. So this produces exactly the correct values.